Welcome to the Dojo Focus Learners. Step inside. Today, we are entirely changing how you approach your Cambridge physics exams. I want you to picture your exam as a martial arts spar. You need to flow like water. You need to adapt your style to any question that comes your way. We aren't just doing a standard run-through of physics formulas in this explainer. No, today is a masterclass in strategy, specifically focusing on the ultimate testing ground, volume and density for Cambridge Syllabus 0625, though these exact tactics will absolutely save your life in 0651, 0652, 5054, and 9702 as well. Look at the screen. I want to introduce you to two students facing a real high-stakes past paper question. On the left, we have Alex. Alex's strategy? Brute force. Alex overloads the page with raw physics facts, dumping every equation he memorized, but providing absolutely zero analysis. On the right, we have Sam. Sam's strategy? Speed. Sam rushes, entirely missing the command word requirements hidden in the question, writing a one-sentence answer that completely misses the mark. Both of their papers are covered in red ink. Sound familiar? Today, we are going to fix that. We are going to build your physics success blueprint so you never get caught out like Alex or Sam.
Okay, let's dive into this. Here is our training schedule for today's session. We'll start by decoding the physical effect mystery, then break down the four-step physics method. After that, we'll master cause and effect, test our reflexes with real-world density applications, and finally, lock in our technique in perfecting your exam answers. Let's start our training with Section 1, the physical effect mystery. We are moving completely beyond memorization here. Remember Alex? Alex memorized the entire textbook. But when the examiner threw a curveball, Alex froze. Why? Because to truly understand physics, we have to start with reality, not just dry formulas on a whiteboard. You have to understand the mystery behind the effect, not just the letters in the equation. I want to pose this question directly to you. What physical effect, measurement, or prediction actually depends on understanding volume and density? Why does this matter? Well, let's look at the 0625 question Alex and Sam were struggling with. The question asked, explain, using concepts of density, why a hollow steel sphere floats while a solid steel block of the same mass sinks. Now, Alex dumped the formula, defined mass, defined volume, and wrote a paragraph about steel. 0 marks. Why? Because Alex didn't answer the core question of what physical effect actually depends on that density change. Starting your reasoning with cause and effect makes you significantly less dependent on memorized wording. When you face an unfamiliar exam question, you won't panic trying to remember a rote definition. You'll be able to reason your way through it. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to the mat. We need a system to ensure we don't fall into Alex's trap of dumping facts or Sam's trap of missing the point entirely. That brings us to Section 2, the four-step physics method. This is your gateway to scientific patterns and the ultimate strategy reveal. We are going to use a framework that top-tier students use to automatically hit every single mark on a question. It completely eliminates the guesswork. To truly master this, you need a reliable, repeatable sequence. Enter the Peel framework, adapted perfectly for physics. Let's walk through this core methodology side by side with our steps. Step 1. Identify the quantity or phenomenon. This is your point. In our steel sphere example, we identify that the phenomenon is overall density. Step 2. State the relationship involved. This is your evidence. Here is where you drop the formula. Density equals mass divided by volume. Step 3. Explain the underlying physics. This is your explanation. Don't just recite the math. Explain that by making the sphere hollow, we are massively increasing the volume without changing the mass, which decreases the overall density. And finally, step 4, connect it to an observation or real device. This is your link. You link it back by saying, because the overall density is now less than water, the sphere floats. Point, evidence, explanation, link, Peel. Sam lost its marks because Sam just wrote step 4 and rushed to the next question. You need all 4. I'm putting 2 answers on the screen right now. I want you to look closely. You have 30 seconds to spot which one actually follows the Peel framework. Go.
Look at how the first one skips the explanation. Look at how the second one hits every single step. That second one is your green checkmark full mark answer.
Moving into section 3, understanding cause and effect, and translating your thoughts into physics. This is where we initiate the transformation. We are going to take those red pen marks and turn them into green check marks. A massive trap, and one that Sam falls into constantly by rushing, is relying on everyday, casual language when answering an exam question. Let's do a live rewrite here. You might think, the object is heavy for its size. We know exactly what that means in a normal conversation, but an examiner is going to slice right through that and give it 0 marks. It doesn't answer the command word. Instead, we must translate that into precise physics vocabulary. The object has a high mass per unit volume. Watch as the red ink transforms to green. It is the exact same thought, but strictly defined. You are explicitly defining density by linking the amount of matter, the mass, to the 3D space it occupies, the volume. It's precise, it's objective, and it shows you understand the exact physical quantities at play. This is the blueprint for success. You aren't just writing words, you are deploying targeted physics vocabulary. And when we apply this exact translation to visuals, like graphs, you cannot just say a line goes up. You must explain the physical meaning behind that geometry. The slope represents a rate or relationship. For instance, on a mass-volume graph, the slope literally is the density. The area under a curve represents an accumulated physical quantity. The direction indicates a vector or a physical change, and the overall shape shows the exact nature of the proportion. Whether the topic involves graphs, fields, forces, or waves, the rule is the same. Insist on clear cause and effect rather than just listing isolated facts. Now listen closely, stop scrolling. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Got it? Good. Let's step back onto the mat. Let's shift our focus to section 4, real-world density applications. Taking physics outside the classroom. It is time for our interactive workshop. I am going to throw scenarios at you, and you are going to apply the PELL framework and our precise vocabulary to break them down. Ideas regarding volume and density are strictly necessary for predicting and improving outcomes in the real world. They appear in engineering, transport, energy systems, and even medical technology. A successful student must be able to pull confidently from these categories. Okay, challenge 1, data scan. I am putting a complex data table on the screen right now, showing the densities of various liquids and solids used in fluid dynamics. You have a 60-second visual countdown timer starting now. I want you to extract the core trend. Look at the temperature columns. Look at what happens to the density of the oils as the temperature increases. Are you seeing it? As the temperature goes up, the volume expands, meaning the density decreases. Time's up. If you spotted that inversely proportional relationship, you are perfectly primed to answer a multi-part 0.0625 application question. So, the crucial point is, simply naming an application like submarines or ships isn't enough. You must justify the link. Okay, challenge 2, find the flaw. I'm showing you a flawed paragraph written by Sam about how a submarine works. It says, a submarine takes in water to its tanks. This makes it heavy. Because it is heavy, it sinks under the ocean. Read that again. I'm giving you 30 seconds to identify the exact sentence that is losing marks. Spot it? It's this makes it heavy. Heavy is everyday language. The examiner commentary would rip that apart. We need to explain exactly why the physics helps us predict the outcome. Let's rewrite it. A submarine takes water into its ballast tanks. This increases its overall mass without changing its volume. Therefore, its average density becomes greater than the density of the surrounding seawater, causing it to sink. Boom, full marks. That underlying physical justification is what secures your true understanding. Which brings us to our final section, perfecting your exam answers and avoiding the common pitfalls. We've diagnosed Alex's fact dumping and Sam's rushing. Now we forge your final bulletproof system. Let's look at this comparison. The ultimate weakness is writing the correct formula without explaining the variables or quoting a process but failing to link it to a physical effect. The strength is using the safest method. Definition, relationship, explanation, application. This is our PEL framework in action. Okay, challenge 3, speed writing. I am putting 30 seconds on the clock. I want you to write one perfect PEL paragraph, explaining why hot air arises in a room, using the concepts of volume and density. 30 seconds, go. Start with your point. What's the phenomenon? Now your evidence, the relationship between temperature, volume, and density. Now explain the particle behavior. Now link it to the rising action. 5, 4, 3, 2, 1. Pens down. If you follow the structure, you just guaranteed yourself 3 to 4 marks on a standard Cambridge structured question.
Here is your ultimate cheat sheet recap graphic. We are bringing that mark potential progress bar all the way to 100%. Here is the complete physics answering system. 3 rules guaranteed top marks. Rule 1, command word decoding. If it says explain, you must give reasons, not just state facts. Rule 2, Peel framework application. Never skip a step. Rule 3, time management matrix. Don't rush like Sam, don't write an essay like Alex. Allocate 1 minute per mark. To ensure you can always execute this, use these 4 memory prompts for your revision. 1, what is the core idea? 2, what changes physically? 3, what quantity or graph shows it? And 4, where is it used? If you can answer these 4 prompts aloud for volume and density, your knowledge is secure enough to handle any paper the examiner throws at you. This quote perfectly summarizes the core philosophy of our dojo today. The best answers show both understanding and application. It's not one or the other. True mastery is bridging the gap between the theoretical formula on the page and the physical reality it represents. Listen to me. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. When you step away from this explainer and look at the engineering wonders around you, how will you apply the cause and effect of volume and density to explain how they actually work? Keep that analytical lens sharp, flow like water, and I'll see you in the next training session.